Beneath your garden, at a depth of approximately 30 centimeters, a creature is active. It simultaneously burrows, flies, swims, and vocalizes, performing each of these 4 feats with a mastery that surpasses most specialized animals. This being predates the dinosaurs. Its acoustic apparatus is lauded in sound engineering textbooks as an exemplary design, so complex that replicating its functionality in a laboratory setting proves nearly impossible. It simply navigates through any opening it encounters. Introducing the mole cricket. You may have considered it a mere garden pest, unaware of its true nature. Imagine a summer morning, a familiar garden scene. Rows of plants stand straight, seedlings are in place. But 3 tomato shoots, upright last evening, now lie prostrate. Their subterranean roots have been severed with surgical precision, as if by shears. 2 small mounds of loose soil mark the disturbance on the surface. This is the sole indication. The gardener toiled through the night and departed before dawn. 25 meters below this serene vista, another world teems. Dark, confined, governed by its own principles, its own architecture, and its own master. The mole cricket. Its scientific appellation is Grilla talpa. Grilla talpa literally translating to mole cricket. 2 creatures are encapsulated within its name, yet this barely scratches the surface of its truth. Fossils of the mole cricket's direct ancestors have been unearthed in Cretaceous deposits dating back approximately 140 million years. It observed the dinosaurs with the same gaze it now directs at your carrots. The dinosaurs are extinct. The mole cricket endures. The mammoths are extinct. The mole cricket persists. Humanity conceived of the garden. The mole cricket colonized it. It has outlasted all. Today, mole crickets inhabit every continent save Antarctica, finding it too frigid even for their resilience. They have conquered all other global climatic zones. I confess, when I began preparing this presentation, I viewed the mole cricket as a simple pest. Unpleasant, tenacious, but understandable. I was profoundly mistaken. By the conclusion of my research, I regarded this creature with unfeigned respect. The mole cricket's body is comprised of 3 distinct modules, each meticulously engineered for its specific purpose. The head serves as the command center. The anterior thorax functions as an excavation machine. The abdomen houses everything else, its wings, spiracles, and sound-producing organs. The mole cricket's forelimb is far more than a mere shovel. Its tibia is adorned with 4 sharp chitinous spurs. 2 are designed for cutting, while the other 2 displace soil laterally. Nature devised the toothed bucket of an excavator 140 million years prior to humankind. The forelimbs of the mole cricket and the mole are a testament to convergent evolution. 2 entirely distinct creatures from separate taxonomic classes independently arrived at nearly identical engineering solutions. Nature discovered the optimal answer twice. During burrowing, each forelimb operates in a distinct phase. As one propels soil forward and outward, the other intercepts the subsequent portion. This creates a continuous, unceasing cycle. Beneath its hardened wing covers lies a second, true wing. It is transparent, elongated, and fully functional. The mole cricket folds it like a fan, concealing it beneath its upper elytra. The vast majority of people remain unaware of its capacity for flight. In May and June, after sunset, mole crickets ascend into the air. Farmers, listening over darkening fields, detect a low mechanical hum, initially failing to comprehend that the sound emanates from a creature within their own garden. Encountering water, the mole cricket simply swims across. The very forelimbs that recently excavated the earth now function as oars. It maintains its momentum, digging, flying, swimming, singing. While many insects possess one of these 4 abilities individually, the mole cricket commands all 4 simultaneously. It is the Swiss Army knife of the insect world. Beneath a single square meter of garden lies an intricate architectural system. Feeding tunnels near the surface, a nesting chamber deeper down, and a vertical shaft for overwintering even further below. All of this is constructed by a single creature weighing approximately 4 grams. The mole cricket constructs its nesting chamber with remarkable care, compacting the walls with its body and smoothing them to a uniform consistency to prevent drafts and excess moisture. This is not merely a burrow, it is an act of construction. Over a single season, one mole cricket excavates up to 20 meters of active tunnels. A creature 5 centimeters in length, responsible for 20 meters of subterranean passages. By morning, new mounds appear. The mole cricket has been at work all night, from dusk until dawn, 6 to 8 hours of continuous excavation. The farmer will discover the results at breakfast. A carrot root, pencil thick, exhibits a single transverse cut. It is not gnawed or nibbled, but precisely severed. The chitinous spurs function like garden shears, but operate underground, in darkness, at speed. Late evening, the garden falls silent, and then, from the earth, a rhythmic, piercing sound emerges. Trrr, trrr, trrr. It intensifies, never ceasing, originating from beneath one's feet. The mole cricket lacks a voice. It stridulates using its wings. One wing possesses a hardened, serrated ridge, while the other features a delicate, vibrating membrane. One wing acts as a bow, the other as a string. But here is the truly astonishing aspect. The mole cricket does not merely sing underground. It deliberately excavates a specialized acoustic chamber shaped like a double horn, facing upwards. Scientists who have studied this structure have described it as being remarkably close to an optimal design for amplifying sound at the creature's specific singing frequency. This is not accidental. It is engineering. The sound registers between 85 and 90 decibels, comparable to the noise of an operating lawnmower. This is the sound emanating from beneath the earth, from a creature 5 centimeters long and weighing 4 grams. Mate-seeking mole crickets are drawn to the song. Research indicates they detect this signal through both soil and air simultaneously, over distances of several hundred meters. The horn-shaped chamber functions as a directional transmitter. When I first read about the mole cricket's acoustic chamber, I had to verify the information. Bioacousticians had indeed investigated its form, describing it as approaching structural optimality, not a random formation, but one honed by natural selection. The mole cricket engineered this horn long before humans understood the principles of acoustics. April arrives, and the soil warms to 8 degrees Celsius. The mole cricket awakens, and the males are the first to begin singing. When a male and female encounter each other in an underground passage, their antennae touch for a few seconds. This is their courtship, swift and businesslike, devoid of elaborate dances. Within a single nesting chamber, the female deposits between 100 and 400 eggs, small and creamy white, each roughly the size of a grain of rice. The female diligently guards her clutch, a rarity among insects. She remains near the nest, regulating the ventilation of the tunnels and responding to the slightest changes in temperature and humidity. An independent mother, armored and equipped with formidable weaponry. After 2 to 3 weeks, the eggshells crack, revealing progeny that, from their very first day of life, instinctively know what to do. Not through learned behavior, but simply because they are mole crickets. Hundreds of tiny, pale replicas of their mother disperse from the nest, each independent, each immediately excavating its own initial tunnel, without instruction or training. The mole cricket is omnivorous. Approximately half of its diet consists of plant matter, including roots and stems. The other half is animal-based, comprising earthworms, beetle larvae, and small insects. It is both a gardener and a hunter. The larva of the June bug is a favored prey item. Large, slow-moving, nutritious, and utterly unprepared for the lightning-fast strike of the mole cricket's mandibles. The mole cricket's mandibles are cutting instruments, not grinding tools. They do not masticate food, they sever it. This explains the clean cuts observed on plant roots. By night, the mole cricket ambushes prey at its burrow entrance, remaining motionless on the threshold, its antennae acting as sensory probes, capturing any insect that passes by. It is the mistress of the crossroads. The mole cricket's primary predator is the toad. Toads learn their schedule, positioning themselves at burrow entrances and patiently waiting. They possess ample time. Starlings are professional mole cricket hunters. Ornithologists have documented instances where a bird listens intently to the ground, tilts its head, and strikes with its beak precisely at the correct location. not by chance, but directly where movement is detected. Hedgehogs can detect mole crickets through 15 to 20 centimeters of soil, excavating their burrows with swift, targeted paw strikes. The mole cricket is aware of this and therefore constructs multiple escape routes. The first line of defense is explosive speed. The mole cricket submerges underground in 2 to 3 seconds. In 3 seconds, it vanishes, faster than a toad can react to its sudden movement. The second line of defense is camouflage. The mole cricket's dark, speckled coloration blends almost seamlessly with the damp earth, rendering it virtually invisible. Even when a predator looks directly at it from a distance of 20 to 30 centimeters, it remains unseen. The third line of defense is its cerci. Should a predator succeed in capturing a mole cricket, its 2 caudal appendages, equipped with sharp, chitinous spines, are deployed towards the attacker. A sting from the cerci is unpleasant even for a toad, and provides the mole cricket with a crucial second to escape. The horsehair worm, a nematomorph, is a parasitic worm that resides within the mole cricket for months. When mature, it performs an astonishing act. The developed horsehair worm releases substances that alter the host's behavior. The mole cricket, which never actively seeks water, suddenly makes a direct, unhesitating journey to the nearest puddle or pond. At the water's edge, the worm exits its host's body and enters the water for reproduction. The mole cricket has served its purpose as living transport and can then continue its existence. It sometimes survives. The digging wasps of the family Sphecidae prey on mole crickets. A sting to a specific point in the nervous system paralyzes the victim, but does not kill it. The mole cricket remains a living food source for the wasp larvae. A paralyzed mole cricket stays alive within the nest chamber for weeks until the wasp larva completes its development. This is not cruelty, it is evolution. Yet, the first time one learns of this, it is chilling. October arrives. Soil temperatures drop below 10 degrees Celsius. The mole cricket alters its behavior. It ceases feeding and begins to construct. It excavates vertically downward, seeking areas where the temperature remains consistently warm during winter. Below the frost line, where temperatures hover around 4 to 6 degrees Celsius, irrespective of the external cold. How precisely the mole cricket determines the correct depth remains a subject of scientific inquiry, whether through temperature receptors, humidity, or other factors. However, the fact that it consistently locates the appropriate level is a documented observation. Within its overwintering chamber, the mole cricket enters a state of torpor, slowing its breathing, reducing its metabolism, and consuming stored fat at a minimal rate. Outside, frosts persist, while inside it is a comfortable plus 5 degrees. It is undetectable and inaccessible. 2 meters below ground, 2 entirely different worlds coexist. Outside, frozen earth and temperatures of minus 20 degrees Celsius. Inside, a constant plus 5 degrees and a dormant mole cricket. Its burrow is the finest thermos that can be constructed with bare appendages. April arrives and the ground warms to 8 degrees Celsius. The mole cricket emerges. Winter has passed and the mole cricket has reappeared. The cycle has concluded. The mole cricket found its way into European agronomic treatises as early as the 15th century, long before scientists could properly classify it. Humans have waged war against the mole cricket for roughly as long as they have written books on agriculture. The score is clearly in favor of the mole cricket. The Encyclopédie of Diderot, published in 1765, features a dedicated article on the mole cricket, complete with detailed engravings. Enlightened Europe, even then, recognized that this creature warranted separate study and presented a distinct challenge. Each summer, the same scenario unfolds. New methods of control, renewed hope, and new wilting sprouts by morning. The mole cricket has not read a single online forum discussing how to combat it. Folk remedies exhibit astonishing creative diversity. Jars of beer are buried, into which the mole cricket crawls and drowns. Rotten fish is interred, supposedly to repel them. Windmills fashioned from bottles are erected. The noise and vibration are intended to disrupt. The mole cricket adapts to everything. Over 3,000 years, humanity has experimented with hundreds of methods to control the mole cricket. The mole cricket has endured it all. The mole cricket holds 5 championship positions simultaneously. No other temperate climate insect is a leader in so many disciplines concurrently. Observations from traps and light lures reveal that during a single mating night, a mole cricket can traverse up to 8 kilometers by air, a record for flight range among temperate climate crickets. Field observations of marked individuals have shown that in one night, a mole cricket surveys a significant area around its burrow, departs, returns, and excavates new tunnels in various directions. A creature the size of a large thumb, working continuously throughout the night. Before emerging onto the surface, the mole cricket conducts reconnaissance. For several seconds, it remains at the entrance, its antennae actively sensing, analyzing scents and vibrations. Only then does it decide whether or not to emerge. Observations indicate that the same individual utilizes the same exit route for several consecutive nights, demonstrating a memory of its territory's topography. Experienced gardeners report that a mole cricket that has previously been trapped and escaped will subsequently avoid that particular type of lure. It learns from its mistakes, though not always, but sufficiently often to be frustrating. In addition to acoustic signals, mole crickets communicate through soil vibrations. Specialized receptors on their legs detect seismic signals from their conspecifics at distances of several tens of centimeters, functioning as an underground telegraph. In natural ecosystems, such as meadows or forest edges, mole cricket tunnels serve as drainage systems and air conduits. They aerate the soil more effectively than most mechanical cultivators. Within an ecosystem, the mole cricket occupies several roles simultaneously. A predator that eliminates beetle larvae, prey that sustains birds, toads, and hedgehogs, and an engineer that loosens the soil. Its removal would cause several links in the food chain to falter. It is a paradox I struggled to accept. In a garden, the mole cricket is a pest. In a wild meadow, it is a beneficial ecosystem component, regulating populations of far more destructive grub larvae. The same creature, a different context. During the 15th to 19th centuries, the mole cricket traveled the globe, embedded in the roots of ornamental plants and within bags of garden soil on merchant ships, entirely unnoticed and entirely without cost. By 1910, the mole cricket had been documented in all states along the eastern coast of the United States. American farmers referred to it as the devil's mole cricket and demanded governmental intervention. Governmental measures proved ineffective. In the 1980s, scientists discovered the first truly effective biological control agent, Steinernema feltii, a parasitic nematode that specifically infects mole crickets without harming other soil inhabitants. In Thailand and Vietnam, mole crickets are consumed, deep-fried, salted, and added to salads. Those who have tasted them describe the flavor as akin to a combination of walnut and crayfish. This is not mere exoticism for its own sake. It is 140 million years of evolution served on a plate. What to make of this is a matter of individual decision. Every summer, millions of homeowners engage in the same ritual. A shovel penetrates the earth, a clod of soil flies upward, and from it, a mole cricket emerges, often directly into a person's face. A cry, the shovel drops, sometimes tears, and the mole cricket escapes. Experienced gardeners hunt mole crickets at night by sound. A neighbor witnessing this for the first time will typically jot down the number for psychological support services. On Russian dacha forums, the topic, "How to get rid of mole crickets forever," has been actively debated since the 1990s. Thousands of suggestions exist, yet the mole cricket remains. Folk engineering in the battle against mole crickets reaches its zenith. Jars of beer, rotten fish, windmills made from plastic bottles, naphthalene, birch tar, pine needles, onion skins. All are genuinely employed. The mole cricket continues its work. In Japan, the mole cricket is known as kera. In traditional haiku poetry, it symbolizes the Earth's hidden life, unseen movement, resilience, and a sign that something is always occurring beneath the surface. In Russia, the mole cricket has been called by various names: earth crayfish, cabbage moth, bear cricket, mole cricket. Each name reflects a single characteristic, not its complete essence. In traditional Chinese medicine, dried mole crickets were utilized as a medicinal component. Descriptions appear in pharmacopoeias dating back several centuries. What precisely they treated is a separate question, but the significance of the mole cricket was sufficient for it to be included in medical texts. The biomechanics of the mole cricket's forelimb have been extensively studied. Several pairs of muscles operate in distinct phases of its digging motion, providing both power for striking and speed for retraction. This mirrors the fundamental design employed in the hydraulic buckets of excavators. Bioacoustic research into the mole cricket's acoustic chamber has revealed that its shape is not a random indentation, but a structure that effectively amplifies and directs sound at the required frequency. Individuals whose chambers functioned more accurately sang louder. Those who sang louder more frequently found mates. Thus, natural selection, over thousands of generations, refined the shape of this cavity to a near-engineering solution. The pads of its feet are covered with microscopic bristles that increase their adherence to soil particles. This is described in entomological literature as a contributing factor to its highly efficient burrowing. Engineers developing grippers for robots study similar structures. Slow-motion video has demonstrated that in digging, each mole cricket forelimb does not move in a